If you've checked your calendar recently, you've probably noticed that we're almost in the month of October, which is by far the best month of the year. But very fittingly, I guess I could say, several spooky CVEs related to Linux systems made the news today. If you're not aware of, let me just pull these up here. Specifically, I'm talking about this critical unauthenticated remote code execution, or RCE vulnerability, affecting CUPS, which is the print server that's often used on Linux and some other platforms as well. And as you can see here, it's been reported with a CVSS score of 9.9. And I guess there was kind of an embargo in terms of releasing information related to the CVE, so a lot of people are getting hyped up about it. And you pair that with a CVSS score of 9.9, well, a lot of eyes are going to be on this vulnerability. And so what I want to do in this video is basically break down this vulnerability, sort of digest it and explain it so we can understand it better, and then we're going to hop into a lab and actually demonstrate a proof of concept where we actually get remote code execution and demonstrate the impact. All right? And I'm going to link everything we cover today in the description, but all of this research basically stems from this person right here, Simon Margaritelli. I believe he's Italian, I'm not going to say his name right, so I will give you his handle here of Evil Socket. And he has a fantastic blog here if I can find it. And this is basically his write-up that he published today titled Attacking Unix Systems via CUPS, Part 1. And so there's going to be a Part 2 to this blog as well, where he goes into more detail in some of the different concepts. But I would encourage you, and I'm going to have this link down below, but I would encourage you to read all of the technical documentation. It even goes through the source code of CUPS and sort of where we actually find the vulnerabilities and what is actually being taken advantage of here. And also, he goes into how he actually discovered the vulnerability itself. And so again, at a high level, this is an unauthenticated remote code execution vulnerability, and these are often the most critical ones. Especially when we look at the impact here. Well, a remote, unauthenticated attacker can silently replace the existing printers or install new, malicious ones onto an actual desktop, right? And it does this, and we're going to get into this, by actually exploiting the IPP URLs, which is a printing protocol that, again, we'll talk about in a second. But it results in arbitrary command execution on the victim itself when a print job is started. Right? And specifically, part of the reason why this is such a critical vulnerability is that it not only affects the LAN, right? So it doesn't only require a local attacker on the network, but it can also affect internet connected devices as well, right? And so anytime you have a remote code execution vulnerability affecting anyone on the internet, well, that's how you get these super high CVSS scores. And to put this massive score into perspective here, well, if you remember Heartbleed from way back in 2014, so 10 years ago now, well, this was a huge vulnerability that impacted the OpenSSL library. And this vulnerability only had a base score of 7.5. Now, if we take a look at, if you remember Log4j somewhat more recently, well, this one had a 10, right? So, this isn't the highest vulnerability we've ever seen, but, it's certainly up there because, again, unauthenticated remote code execution from internet-facing systems. It's always going to be huge. And so if we take a look at the summary, you can see there are different CVEs here, right? Because these are all slightly different but interconnected vulnerabilities that kind of chain together to make this possible. Right, so we have CVE 2024-47176 with CUPS browsed here. And the problem here is that the CUPS service binds on the UDP port of 631 for any IP address. And basically why this is a problem is because it trusts any packet from any source, right, any external source, to trigger a getPrinterAttributes IPP request, and we'll take a look at this protocol in a second, to then sort of reach back out to any attacker-controlled URL, right? And so what we're going to do when we take a look at the proof of concept is set up our own malicious server to handle and receive these responses. And one of the first things the author found here is that if we just run a netstat with an ANU, well, we can look at any of the UDP ports listening, right? And this is it right here. We have 631, or the CUPS service here, which is listening, and this herein lies the problem basically, is that it's listening on every address, right? And so this means that any packet from any source can sort of trigger this to happen, right? It's the perfect combination of both listening for every packet coming in and also not being able to handle these packets or not being able to trust where these are coming from and blindly sending information over back to the attacker in this case. These two CVEs here come into play as well because they fail to sanitize and actually validate the IPP attributes that we're returning. And lastly, this one here, 2024-47177 with CUPS filters, specifically this foomatic-rip plugin, I guess is a better way to put it, allows arbitrary command execution via its actual command line parameter, right? And if I just do a search for foomatic-rip, well, this is kind of the crux of what's going on here, right? And this actually isn't the first time that it's been leveraged or used for exploitation or remote code execution. We can go all the way back to 2011 with these two CVEs here. And so I guess the problem therein lies is that this is a known issue, right, to the developers of cups, but it's not been fixed in over 10 years. And we actually have a quote from the developers here. Apparently it's a very hard vulnerability to fix, right, because it needs to have this functionality. Not only for backwards compatibility, but also just for printers to function, right? We think about all the different printers that we're putting on our network. Well, they need to use this directive in their own different ways, right? So they might need to run Perl commands. They might need to run, whatever this is. And so the crux here is that, the developers have to allow this to accept pretty much anything, right? Including Perl. And without this, a lot of printers are just going to stop working on any Unix-based system. And so you can sort of see the pickle or the problem here. But the big question now is, well, how ubiquitous is cups, right? We know it's a pretty bad vulnerability, but how many devices are affected? And if we just head over to Shodan here, for example, and just do a blanket search across the internet for any internet-connected device on port 631 or the cups port, the default one, and specifically we can filter this more with the product header, and in quotes here, I'm just going to search for cups, and in brackets here, IPP. And so this is going to filter out anything else potentially listening on the same port. So if I do a search here, well, we return 74,296 devices at the time of recording. And I'm going to need to blur out this entire middle section here because these are all potentially real devices on the internet with real IP addresses that you can access that are vulnerable to this remote code execution. And it doesn't mean that every single device that we see here is in fact vulnerable, but they have the potential to be vulnerable, right? They meet the requirements. And so be very careful. Don't just go, scanning random devices. Again, I'm using Shodan here, so all of this is basically passive reconnaissance. And let's get real here for a second. Don't start probing any of these devices that you come across. Don't try to scan them. Don't try to do anything. Do not touch them. First of all, it's illegal. Second of all, yeah, you're going to get in trouble. And third of all, these could be honeypots, right? Now, anyways, the real question you're probably asking now is what the heck is cups, right? And what does it have to do with Linux or Unix-based systems? Well, it's not this kind of cup, right? It's actually an acronym, right? So cups, or the Common Unix Printing System, is a kind of modular-based printing system for Unix-like operating systems, right? And it's not just Unix-based systems. You could see it on Mac OS, right? Or some BSDs, or even things like Chrome OS or Oracle Solaris. And it's basically just a service or a daemon to manage printers and print jobs, right? So it gives us the ability to add printers, configure them, manage them, and remove them from our devices. And it also allows us to queue up print jobs, right? And manage spooling of our different printers on our network. And it does this through different protocols, right? So we have things like IPP, or the Internet Printing Protocol, which again, I keep saying we're going to talk about in a second, and we're about to. But also things like SMB and LPD, or Line Printer Daemon. But a main thing here to point out is that this is enabled by default on these desktop systems, right? You often won't see it on server configurations, but on, desktop Unix-based systems or Mac OS systems, maybe in some cases, but, these desktop Ubuntu systems, for example, you're going to see it enabled by default. And I've mentioned IPP, or the Internet Printing Protocol, quite a few times already. And forgive me, I'm going to pull a bit of a pirate software here and open up Microsoft Paint so I can do a little bit of whiteboarding here, right? And so we have IPP, right? The Internet Printing Protocol. And it's sort of this protocol or set of functions or APIs, again, a protocol that we can interact with printers or print services on our network, right? And so cups uses IPP to communicate with various printers that you load in or manage on your network. And with IPP, well, we can think of it like any other protocol, like HTTP or FTP, in the sense that we have a universal resource locator, or what we commonly refer to as a URL, right? And so with IPP, well, this is our URL, right? And so we have the IPP protocol, and specifically the structure of an IPP URL is going to look something like, well, we're going to have our host name with our specific port, right? So 1234, whatever port our, IPP server is listening on. And then we're going to point it to a resource, right? And the problem with this vulnerability, or the crux of this vulnerability, is that this can be our attacker-controlled machine, meaning that this hostname can be any attacker-controlled server out on the open internet. And remember when I said CVE 2024-47176 is due to the cup service listening or binding on any IP address, meaning that any packet from any source, as long as it includes one of these URLs here, is going to trigger the getPrinter attribute request to this malicious attacker-controlled URL. And so this is going to make more sense once we actually set up our IPP server. Which, by the way, why don't we just go ahead and jump right into it, because I know that's what everyone's here for. And at the time of recording, this is the only proof of concept that I know is out there. At least I haven't really checked in a couple hours. I've been meaning to record this video earlier, but I was playing Bloons Tower Defense this evening, so kind of got a little distracted. But this is actually called Cups Hacks, which I'll have linked down below, and it's created by Rick DeJagger. Right? And so what it basically is it's going to sort of abstract a lot of the technicalities when it comes to actually setting up our own IPP server. We could do it with Python, and if we look at the actual evil socket documentation here, if I just do a search for IPP, what is it called? Server? Yeah, so there's actually a Python package that if I just open up here, we can basically just stand up our own minimal IPP server. And we could, in theory, work around this to sort of make this exploit work, but again, where are we here? This repository is perfect. It has all of the abstraction that we need. We basically just need to set it up and run it ourselves. And it's going to allow us already to just inject a command and basically get that remote code execution. But before we do that, again, I'm going to demonstrate and sort of work towards it slowly so we understand the concepts and basically what is going on and basically the sort of very minimal research that I did when I just found out about this vulnerability. And so I just have two different VMs running in our little lab here. So I have a Kali Linux machine, which is going to be obviously our attacker in this scenario. And I just have a pretty bare bones standard Ubuntu desktop installation, right? So this is a fresh installation. If I just run a uname tac A, we can see the results here. Again, this is going to be our victim in this case, and it is vulnerable just out of the box, right? This is an Ubuntu desktop machine. In fact, I can just run an lsb_release tac A. Okay, so in this case, it is a 22.04 release. However, let's hop over to our Kali Linux machine, right? So I'm gonna type in my password here, and I'm just gonna create a directory just for our staging here. And I will zoom in a second. There we go. All right, so what I wanna do to demonstrate this is to first just set up a very basic netcat listener, right? So we're gonna pretend that this is eventually gonna be our listening server, but in this case, it's just gonna be not an IPP protocol server, it's just going to be a netcat listener, right? Because I want to demonstrate what this actually looks like first, right? So I'm just going to listen on port 1234, all right? And then in a new tab, all I'm going to do is write a very simple Python script using the Scapy library. And in doing so, it allows us to craft our own packet, which we're going to use to basically trigger this, first stage in the vulnerability here. Right? And so I'm just going to call it packet.py, and I'm just going to import the Scapy library. And next, I just want to construct our individual packet that we're going to send over, right? And so we're just going to call this packet, and we're going to set that to equal IP. And so in this case, we actually need the destination IP address, or the IP address of our victim. And so if I just run an ifconfig on my Ubuntu machine, if I can spell, we're going to get, where are we here? 10.0.2.10, okay? So I'm going to copy that over and set the destination here as 10.0.2.10. I can close that, and with a slash here, this is just the syntax for Scapy. I'm going to set this to be a UDP packet that we're going to send over, obviously, because this is going to be communicating with, again, that IPP protocol, or the CUPS protocol. And in this case, we're going to have the destination port of the default CUPS port here, which is going to be destination of 631. All right, and now we want to inject the actual data that we're sending over with this packet. And if you remember when, I still don't have Paint opened up, but I'll just put it over the screen here, we have that URL that we want to send over, right? And we're going to send over the URL to our own listening server. And so to do this, we're going to set up a raw packet, or the raw data here. And within brackets or parentheses here, we're going to load in, and we're going to set it to what the actual CUPS server is going to expect, right? And so if I head back to our actual write-up here, I'm going to find where we have this packet documentation here. And so you can see we have the number 0 with a space with 3, and then the actual IP address of our attacker machine, the port, /printers, or the resource, and we can just, point it to whatever resource we want, right? And so I'm just basically going to copy this, and we're going to modify it a bit. But this is the actual packet and the data within the packet that the CUPS, service is expecting. And this is what's going to trigger that sequence of events that is going to result in the CUPS browse, daemon or service connecting to whatever URL we provide in a kind of drive-by attack, right? And so it's going to make a request back to ask, hey, like, what kind of printer are you? What is your name? That kind of thing. And so I'm going to head back over to my machine here. I'm going to paste in that URL, and I'm just going to change this. Well, we can leave it on /printers/ whatever. It literally does not matter. But for the port here, if you remember, we're listening on port 1234. If I go over to attacker IP, this is going to be the IP address of our own, attacker server, right? And so what I can do is just open up a third tab here and just run ifconfig. And our attacker machine is 10.0.2.8, right? So I'll copy that, paste it in for the IP address, make sure everything looks good. Actually, instead of dest, I believe under the UDP here, this needs to be dport. All right, so that looks good. And then all we need to do now is just basically send over our packet, right? So we can call the send function and just put in our packet object. And then for good measure, we can just print and just say, something like packet sent over to 10.0.2.10, and that should be good to go. And so I'm just going to run a sudo python3 against that packet.py. We can see that we sent one packet and the packet was sent over to 10.0.2.10. If we head back over to our listener, oh, there we go. So we're actually getting some interesting things. And this is the IPP protocol in action, right? So let's take a look at what we actually got, because again, we were listening in verbose mode with netcat, right? So we're going to get any response from, or any requests coming in, right? We're going to see basically everything. So all of the request headers and any of the data sent over, right? And it kind of looks like a weird kind of mess, right? And so you can see we got a connection from 10.0.2.8, which is in fact our Ubuntu server. And we didn't do anything on our Ubuntu machine to, call out to our attacker machine, right? So this is interesting. We can see that it actually made a post request to whatever, URL that we gave. So in this case, /printers/whatever. And interestingly, we got the user agent, right? Which contains a lot of interesting fingerprint information, right? So we can see the actual Linux architecture. We can see the kernel version, right? So a lot of interesting things here. We can see the version of cups as well, right? And so this is a bit of an information leakage vulnerability as well. But obviously we're here for the RCE, but again, I just want to demonstrate what we actually get here and what we're actually doing over the network. And you can see this object or this, this data that's being sent over, which is again, specific to that protocol. But in this case, it's expecting the requested attribute here, right? And so what it's essentially waiting for us to do is basically tell it information about our print server, right? So it can actually add it onto the desktop or the Ubuntu machine as an actual print, option to print from. Not the best way to explain it, I guess, but again, this will all make more sense when we actually execute the payload. What we could do, again, is just I'm going to set up our listener once more, and I'm just going to open up Wireshark, right? So just going to call up Wireshark so we can open it up here, listen on Ethernet 0, which is my listening, the actual interface that I'm using here, and we're just going to send over that single packet once again and see what we get with Wireshark. You can see some traffic was logged. And we have some interesting information here, right? So we have some broadcast information and whatever, but really what we're looking for here is the TCP stream here, right? So between 10.0.2.10, our Kali machine, and 10.0.2.8, which is our Ubuntu machine, I believe. Did I get that backwards? No, we're good. So what I can do is just follow the stream here and see what actually happened. And we're getting the same thing, right? And if we jump back a second, you can actually see it's categorizing this as a DNS protocol. And if we look at the UDP stream, well, this is the actual request that we made over to the Ubuntu system. And so in this case, you can see the actual URL values that we sent over. And you can see, interestingly, we have an IPP request here, right? So actually, I can zoom in. I never knew you could do that with Wireshark, but it makes things so much easier. But we have this actual IPP request that it's sent back over, right? And this is this actual HTTP stream that we can look at. And this is saying like, hey, give me this information that I need to basically configure you as a printer on the network. And so that's what it's basically doing under the hood or over the wire. And so let's get into the fun stuff now, right? So, that was cool and all, but let's actually do something with this instead of just pulling back, fingerprint information and not knowing what to do, right? Because we need to actually stand up an IPP server to handle these requests, right? To actually respond to that get attribute request. And in this case, use that other vulnerable function to actually execute code, right? To actually execute commands on the Ubuntu system. And so what we'll do here is just open up that GitHub repository once again. And I'm going to do a good old git clone here. And I'll just keep this in our staging directory here. I'm going to hop into cups hacks. That's a better way to put it. CD, I can't spell. It's actually 2 a.m. right now, basically. So we basically just need to run it, right? And the best way to do this, because we have to actually install, if we go back to the repository here, we have to run or install or import the zeroconf and the IPP server libraries for this to actually function, right? And so what we can do instead of messing around on our operating systems versions of pip packages and everything, we can just set up a virtualized environment, right? And so what I'll do is just run Python 3 with the M for module, and I'm just going to run venv to actually set up a virtualized Python environment. And I forgot I need to name it, so I'm just going to call it venv. And that's going to create a directory called venv in our actual folder here. And so what I can do now is just source it by targeting venv, going under bin for binaries, and then activate. If I run this, you can now see we're in this virtualized environment. And from here, we can install anything we need to, right? So I'm just going to run a pip install for zeroconf and for IP server or IPP server. And this should just take a second. Cool. So now what we can do, we have all the requirements basically. We can just run cupshacks.py, right? So Python 3, cupshacks.py, and it's going to yell at us about the usage information here because this is actually surprisingly a well-documented proof of concept so far. And so what we need to do here is basically put in the IP address, right? And this is going to be the IP address of our listening server, right? So again, if I run, in this case, an ifconfig, we are 10.0.2.8, right? So that's what we're going to be listening on. We can set a port number as well. There is a default one, but in this case, we can once again use port number 1234. Interestingly, we can set up the name of the printer itself, right? So this is actually going to be the name. And again, this will make more sense in a second, literally a second, not literally, but this allows us to actually set the name of the printer that's going to appear on the client's end, right? So in this case, I can just set the name, do something very fitting like evil printer. And finally, we can list out the actual command that we want to run on the victim, right? And so we can get pretty creative here, right? This is remote code execution once again. But in this case, again, as a proof of concept to make sure everything's working, I'm just going to run the touch command to generate or create a file under the temp directory, and we'll just call it pwned, right? And so we're basically ready to go now. But what I want to do is just start up Wireshark once again, because I want to show you what's actually occurring when we run this command, right? We shouldn't just be running scripts and proof of concepts or exploits without knowing or understanding what is actually going on, right? So I'll head back over to here and just hit run here to execute our Python script. And you can see it's starting up the IP server on this port, and it should be ready to go. Right? So if I just hit stop here, we have a number of packets that were sent over. And interestingly, we have a lot of MDNS or multicast DNS packets, right? And so this is basically our listening server, our malicious server saying like, hey, look at me, I'm a new printer on the network, right? So you can now configure me kind of thing. And so it's sending out this broadcast to everyone on the network. And so this is kind of how this proof of concept works, right? And so it's sending out this broadcast message for printer discovery, which we can see through these different MDNS packets here, right? And so if I just follow this stream, for example, we can see it's sending out, this address here, this host name. It's the name of our printer, evil printer, and it's all kind of in this IPP protocol format, right? And so we can see all the different types of information that our script, our little Python script, is standing up for us using the IP server library. But what's even more interesting now is if we hop over to our Ubuntu machine, right? And so, just need to sign in here. What I'm going to do is just open up the web browser. Oh, there we go. I already have it. So I have this very nice photo of a cat that I want to print, right? I want to print it out and put it on my wall just behind me here. What I'm going to do is just in my browser or whatever application that I'm using, right? You can print from basically any application these days. In this case, in Firefox, I'm just going to click on print or press Control P. There we go. And so if I click on destination here, right, where we can actually configure and select what printer we want to use, well, look at that. We have evil printer. We didn't do that. We didn't do this setup on our, desktop, right? This was automatically configured through that multicast or that broadcast that was sent out to everyone on the network, right? And so what I can also do to demonstrate this, if I just go and search for printer in our settings here, you can see we have evil printer. It's ready. It's stood up. It's configured. It's ready to go. We can even click on printer details here. And so we can see the name of it. We can see the address. So again, that local address that it set up for us during that multicast. And so this is super cool, right? We didn't compromise ourselves yet, but we have put our evil printer, our malicious server, onto this system as a configured printer, right? And so you can imagine instead of calling this evil printer, well, it could be something legitimate, right? It's legitimate sounding. Maybe we do some OSINT or research, or we know what common printers that this company is using, and we set that to the name, and we'll demonstrate that in a second. But there is some interaction that needs to be done in order for our actual remote code to execute, right? You might be thinking like, well, we entered this command, where did it go, or what happened? Nothing yet, right? What we need to do, we need to hit print. But before we do this, I'm going to demonstrate that if I just open up my terminal here and just list out everything in the temp directory, right? And so you can see we don't have any pwned file listed here yet. So with evil printer selected now, I'm just going to click on print. You can see at the top there, our job was sent to the printer. And if we go back to our terminal now, if I just run another ls on the temp directory, well, there we go. We can even see we got a message at the top there, printing stopped. That's fine. But you can see this file here of pwned. That's what we created with our remote code execution, if that's not clear. And if I just see who owns this file, well, you can see it's LP for the line print service or the service account. And so there we go, right? We got remote code execution on our server using this proof of concept. And so let's take this a step farther now and actually, get a shell, right? And that's what we're here for. The fireworks and, the elite level hacks. We're not here to just create or touch a file in the temp directory, right? We're here to actually drop some malware or to actually get a shell on our system, right? Because that's more fun. And so what we can do is, well, we don't need our Ubuntu machine because, again, there's not much user interaction here other than printing a file, right? And using the malicious service, or the malicious printer, rather. So what we can do is just close out our server here. And let's just change up our command to start up our server a little bit, right? And so what I want to do first is get a little bit more OPSEC going, right? So let's try to social engineer a user a bit more because, again, this relies on a bit of that interaction from the user. And so instead of just calling it something is noticeable as evil printer, well, let's just look up a common printer name, right? Like HP DeskJet. I've dealt with a lot of those in my IT career. We can say this is the 3755 model, right? We can leave the port and the IP address the same. It doesn't really matter. Well, the IP address matters. And for the command, well, we don't just want to touch a file, right? Let's actually create a reverse shell. And so what I need to do first is actually set up a listener, right? So I'm just going to run netcat listen on port. Well, we're being super elite level hacks here, so I'll just do quad 4 for the port. And we just need to make a callback to our listening server, right? So what I'll do is just head over to somewhere like revshells.com and put in my IP address and port, and it can generate a reverse shell for us, right? And one that usually works for me is this make FIFA one. It's pretty reliable in these situations, and so I'm just going to copy this. We will spawn a bin bash shell, and let's paste this into our command and see how it goes, right? So that looks good. We're going to call back, make sure the IP address is right for our listening and our listening port. All good. We could obviously do this with Meterpreter or whatever, but again, we're just being lightweight here. No big deal. So we're starting the server now. Excellent. And let's head back over to our Ubuntu machine. And same kind of deal, right? If I go back to printers, what we could do is just to be safe here. Oh wait, no, it's already there. We changed the name, right? So we have HP DeskJet 3755, right? Looks good to me. That is the printer I use every day, right? In the office or, whatever scenario this is. And again, I want to print out this really cute cat photo. So I'll click on print, change the printer to the actual HP DeskJet here, and we'll just hit print. We can see it was sent over to the print server, our malicious server. And if we head back over to Kali Linux, we should catch the shell. We did not. Okay, interesting. I wonder if this is because it's dealing with this IPP protocol, right? So some of these characters might be messing it up. It might not be able to handle multiple commands, maybe. So it could be something like that, right? But there's ways around that, right? We could drop a file, right? We could just drop a file onto the server, make another request, and execute it. That could be a thing. But in this case, what I tend to think of is why don't we just encode it, right? If I head back over to reverse shells or revshells.com here, I can change the encoding to base 64. And yeah, that looks good. And so it's going to run the same command, but it's just base 64 encoded. And so we'll need to decode it, obviously, but that's pretty simple to do, right? For example, if I just open up a new terminal here, I can just run, I can echo out this string, right? We don't even need it in quotes. and then I can just pipe it over to base 64, tac D to decode. And again, that's what we're going to do. We're going to execute this. And what we can do further is just pipe this over to bash, right? And you can see that that's a good sign. That is an error, but it's a good sign because we should have caught our shell, and we did. This looks very confusing, but it's because we caught our own shell on our own, host machine here, right? So that looks good, right? That's all we need to run basically is just paste in or type in echo, paste in that base 64, pipe it over to base 64 tac D, and then pipe it over to bash to execute it, right? It's like every one of my videos, I'm just piping something in to bash or something to execute or PowerShell in the last video. So I guess that's my preferred way of doing things, I guess. So cool, let's run this. Should be good. Head back over to our kitty. And I think we're just good to go, and we can just try to print this once more. So it's already selected on our HP desk jet, so we're good to print. Hopefully this sends over. There we go. Let's check our listener. There we go. We got a shell. Who am I? We are LP, or the line print service account or service user, whatever, right? Yeah, that's it. It's been so long since I've done any hacking, quote unquote. I don't even know what commands people run these days. We could run sudo tac L. Oh, we need a password, and apparently we're not in a teletype terminal that can actually type in a password. How do we do this again? Control Z, STTY, raw minus echo. Oh, I'm gonna mess this up and look like an idiot. I don't want to look this up though. Pipe this over to foreground, right? Or right foreground, and we need to export the terminal variable to xterm is the one I typically use. Again, I haven't done this in so long. There we go. No. Anyways, we got a shell, right? We got a shell. Who am I? Someone will tell me what I did wrong there. Anyways, it doesn't matter, right? We got our shell. We got remote code execution. We own the machine, basically, as a low privilege user. I haven't actually looked into what privilege escalation looks like for that LP or that line print user. But I'm sure there are things out there, but that's not really relevant, right? The point is we got the proof of concept working. Super cool vulnerability. Let's talk about mitigation for a second, right? And also impact in a way, right? Because again, this affects any system where we have that cups print server installed and enabled and running. And most of the time, this is going to be desktop servers like we have on our Ubuntu desktop machine, right? Not really on servers, right? On these headless servers that most of our Linux hosts are actually running, right? And so when we think about mitigation, well, if you're not using the print service, just uninstall it, disable it. I believe the Red Hat distro, look at the Red Hat bulletin on this vulnerability, right? We go under to detections. Well, we can actually detect this. I guess in this case to determine if cups browsed is running, which, yeah, we can do, whatever. The mitigation in this case is to simply just stop the service and disable it from starting up every time we restart, right? And so, yeah. What we could also do, again, is just block that port 631. And this is because, again, I don't believe there's a patch out yet. This is still kind of breaking in a sense, even though it's a couple hours old now, just because when I got around to it. But there could be a patch out by the time this comes out. We could also just block UDP port 631, right? Because that's the default port for what cups is listing on. But at this point, yeah, it's a high score, man. But I don't know if the impact is there. Maybe someone can tell me down below, like, why would this be, why is this rated so high? I mean, I get it, right? It's remote code execution, unauthenticated, internet-facing servers. But in the enterprise, who's running a desktop Linux service with the print service, the cup service enabled, and is also open to the internet, right? I don't know. But I get it. It's a really cool vulnerability. It's so cool how you can just add your own printer to someone's unsuspecting device, right? Especially when we look at the LAN, right? Or the actual local network when we're actually sending out that multicast message, which is really cool how we can actually target multiple people, right? So, but yeah, I hope you found that interesting. I didn't really get to do much research into this. I kind of just, it just sort of happened earlier today, at least when I read about it. So just wanted to get a video out there about the proof of concept because, again, right as I hit record, this kind of thing came out. And so it's cool how that all kind of worked out. And so, yeah, again, hopefully you enjoyed. I'll try to do some more cyber in the news kind of videos and actually make them technical in a way where we're actually, catching shells and stuff, because that's always fun. I don't just like talking about things, I like to actually do things. Hands-on keyboard, right? So yeah, I'll catch you in the next video, and let me know if you have any information to share or concerns, comments, whatever. I would love to hear your thoughts down below. So thanks again, and have a great night. I'm gonna catch some sleep so I can hopefully function tomorrow at work, because it's 2 a.m. So take care, everyone.